Okay. Whenever we talk about the unit circle, that's what I hear almost. What did you say? Who said? Okay, it's out there. I don't think it's necessarily too hard because something about the unit circle is it follows a particular pattern. And if you're just kind of aware of the pattern, it makes it a little bit easier. And I'm going to try today to make it as relatively painless as possible. Okay. Well, before we start getting to the unit circle, let me show you how, in a way, we've kind of done stuff like this before. It's just now the landscape is a little bit differently. So if I were to plot a coordinate, let's say here, and I told you, tell me the location of that coordinate. Tell me what the coordinate is of that particular plot. I'm pretty sure all of you are aware of the fact that you would have to go right 3 and up 2 for a coordinate of 3, 2. That's how we locate a point on a coordinate plane, right? Remember? Okay, good. Pretty much what we're doing today, except instead of a coordinate plane, we have a circle. Now they have provided you 1, 2, 3, 4 circles on page 1. I'm going to use this picture here because it's much bigger than what they have provided me. Just know that the information that I'm going to write here goes for this circle here. Then whenever I bring up a second page, it's going to go for that circle there and so on and so on. Okay. So when it comes to the unit circle, we're going to be incorporating quite a few things that we learned last class. Now for the first circle here, this is going to relate to the 30-degree family. So one of the things that we went over last class was how to plot a terminal ray. And the way that we do that is from your positive x-axis. If I said, hey, plot a terminal ray that has 30 degrees, then you would just do a 30-degree rotation and then draw your ray. Right? That's what we did last class. Now, where's that piece of paper that had a little bit of it? Okay. This coordinate that we did just a little bit earlier, it has a coordinate of 3, 2 because we had to go right 3 and up 2, right? We had to go right 3 up 2, correct, I guess I should say. This point right there also has a coordinate, if you will. But it's not as like clean as 3, 2. In order to get to this coordinate here, we'd have to, from our origin, go to the right a little bit and then up a little bit, creating a right triangle. More specifically, a 30, 60, 90 triangle, but whatever. All right, so the coordinates of a 30-degree reference angle on the unit circle is √3/2, comma, 1/2. So let me compare again. This plot right here has a coordinate of 3, 2. This plot right here has a coordinate of √3/2, comma, 1/2. Now, last class, we also learned about reference angles. Reference angles simply means the distance of your terminal ray and its closest x-axis. So the distance from here to here. Well, there are 3. Here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. In these remaining quadrants here, we have 3 other 30-degree reference angles. So we just took care of the first one. The next one's going to be somewhere over here. What that is from the positive x-axis, that is a 150-degree rotation that creates a reference angle of 30 degrees yet again. The distance from here to here is 30 degrees. Now let me go back to what I drew a little bit earlier. If I were to simply take this coordinate and reflect it over the y-axis, it would be here. This coordinate here is now -3, 2. Agree? All right. So what do you think this coordinate's going to be? Anybody? Well, if this one right here was root, there you go, comma what? Comma 1/2, yeah. This point and this point are reflected over the y-axis. So the numbers are going to be the same, but something might change from positive to negative or vice versa. And that's exactly what happened here. So this point here that is reflected over the y-axis from that point is negative root 3 over 2 comma 1/2. Okay, so we've taken care of the 30-degree reference angle in quadrants 1 and quadrant 2. We have another 30-degree reference angle in quadrant 3. That would be our 210-degree angle. Okay, hopefully you're aware that my numbers here are going to be the exact same, except they might change from positive to negative or negative to positive. What are the signs going to be of my two coordinates here? They're both going to be negative, right? Because in order to get to this coordinate from the origin, we have to go left a little bit and then down a little bit. So left, down, negative root 3 over 2, negative 1/2. Good. And then we have another 30-degree reference angle over here in quadrant 4. That would be a 330-degree rotation. That would produce a coordinate of root 3 over 2, comma, negative 1/2. Okay, I'm going to go back to my original coordinate plane. Here we have an x value, here we have a y value, right? Here we have an x value, here we have a y value. Well, some thing that's going to change about these coordinates here is we're not going to refer to them as x and y anymore. We're going to refer to them as cosine, and sine. So rather than x values and y values, we have a cosine value, we have a sine value now. Now, one other thing that we're going to add to this, and then we'll pretty much be done with our 30-degree family here, is, so if we had to get to this coordinate here, we go right 3 over 2, right root 3 over 2 units, and up 1/2 units. But it kind of produces a slope, doesn't it, in a way? From the origin to that point, there's a little bit of a slope there. The slope for your 30-degree family is going to be root 3 over 3. Now, previously with rectangular coordinates, like here, slope, we used the letter M to signify slope, right? But since we're doing things a little bit differently, since this is now cosine, this is now sine, we're not going to refer to this as slope anymore. We're going to refer to this as the tangent value. Now for a 150-degree rotation, it has a tangent value of root 3 over 3 also. But do you think this one's going to be a positive or negative value? Negative, because yeah, doesn't it kind of look like it's producing a negative slope here? So your tangent value for 150 degrees is negative root 3 over 3. Your tangent value for 210 degrees is positive root 3 over 3. And your tangent value for 330 degrees is negative root 3 over 3. Now here's how you're going to apply what we have just done here on your assignment for today. It might give you something to solve, such as, what is cosine of 150 degrees? And all that means is, look at your 150-degree cheat sheet and figure out what is the cosine value of 150 degrees. It's negative root 3 over 2. So that would be your answer. If I said, what is cosine of 150 degrees? You'd say, oh, it's negative root 3 over 2. If I asked you, what is the tangent value of 30 degrees? You'd go over here and figure out, well, which one of these numbers represents the tangent value? It would be root 3 over 3. So y'all tell me, what is sine of 330 degrees? Negative 1/2. Very good. So 330 degrees is over here in quadrant 4. We have a cosine value. We have a sine value. So sine of 330 degrees is -1/2. What is going to be your tangent value of 150 degrees? -√3/3. So tangent of 150 degrees. Let's locate our 150 degree quadrant first over here in quadrant 2. And what is the tangent value of 150 degrees? Right here, -√3/3. That's pretty much it. All right, that covers the first circle. That covers your 30-degree family. Let's now move on to the second circle, and we're going to do the 45-degree family. 45 degrees. All right, 45 degrees. If I were to tell you, plot the terminal ray of a 45-degree angle, it would look like that. Right in the smack dab between 0 and 90 degrees. And in order to get to that coordinate from the origin, we'd have to go right a little bit and then up a little bit, which would produce a 45, 45, 90 triangle. And the coordinate of this one is going to be √2/2 for cosine, √2/2 for sine, and it's going to give you a tangent value of 1. Cosine, sine, tangent. So for your 45-degree reference angles, your cosine and sine value are the same numbers. They just might be positive or negative, just depending on which quadrant they fall in. All right, our next reference angle that produces a 45 degrees is going to be over here in quadrant 2. Right smack dab in the middle of 90 degrees and 180 degrees. So what would that be, 125 degrees? 90 plus 1, 9, 10, 11. Yes.
Like,
No, 135. My bad. 135.
oh, no, that's
Okay, go ahead.
these the cosine sine stuff.
Uh-huh.
You have to memorize it.
Well, you have to memorize,
Like what the 45 is.
you like it, like the, so we have to remember √2/2, comma √2. Yes, yes, you will. We'll need them. I'm sorry, say that one more time.
We'll you have like every 15. Like now it's 30, 45.
Yeah.
60.
Yeah, so the ones that we're going to have to know are 30-degree reference angles, 45-degree reference angles, and 60-degree reference angles. And then I don't know if you noticed, but there's a fourth circle on here too, right? So those are going to be your quadrant angles, and those are a little bit easier to memorize. But if you'll probably notice a pattern here in a little bit, but 45-degree reference angles, 2 of the numbers are the same, right? So that's not that hard to remember. Just what you would really need to remember is it produces a tangency of 1, right? Now over here in quadrant 2, our 45-degree reference angle, remember from here to here is 45 degrees. It's going to be the exact same numbers, except the signs are probably just going to change a little bit. In order to get to this coordinate from the origin, we would need to go left and then up. So that means our cosine value is going to be -√2/2. Your sine value, +√2/2. What about your tangent value, positive or negative? Negative, -1. Over here in quadrant 3, we have 180 plus 45, 225 degrees. It's going to have a coordinate of -√2/2, -√2/2, and a tangency of 1. Over here in quadrant 4, we have a rotation from the positive x-axis of 315 degrees. That coordinate's going to be √2/2, -√2/2, and a tangency of -1. So as long as you memorize quadrant 1, your 30, 60, 90 angle, or I'm sorry, your 30, 45, 60 angles. It's kind of easy to apply them and how they would go in quadrants 2, 3, or 4, and so on. Okay, that takes care of the 45-degree family. Let's now move on to the 60-degree. So this is going to be your information for the third circle on page 1 of your notes. If I were to tell you to draw a terminal ray that has a rotation of 60 degrees, probably be somewhere right around there. This coordinate has very special numbers. They are 1/2 for cosine, √3/2 for sine, and √3 for your tangent value. Cosine, sine, tangent. What do you notice about cosine and sine compared to a 30-degree? They're just switched. So it's not that much memorization, really. Your 30-degree and your 60-degree sine and cosine values just switch. Just notice that your tangent isn't, it's a little bit different. Instead of it being √3/3 like it was for your 30-degree, your tangent for this one is just simply √3. Okay, let's now fill in the rest. So over here in quadrant 2, 120-degree rotation from the positive x-axis would create a 60-degree reference angle. Our values here are going to be -1/2. √3/2 with a tangency of -√3. A rotation of 240 degrees from the positive x-axis would create your next 60-degree reference angle, and that coordinate is -1/2 -√3/2 with a tangency of √3. And then we have 300 degrees. A 300-degree rotation from the positive x-axis is going to create your final reference angle of 60 degrees. And its coordinates are those right there. So somebody tell me, what is cosine of 300 degrees?
No, 1/2.
1/2. Yeah, you gave me the sine value. That's yeah. Cosine of 300 degrees is 1/2. What is I don't know. How about sine of 60 degrees? √3/2. What is tangent of 120 degrees? Negative √3. What do we think so far? Yeah, not too bad. Dipping our toes into the unit circle. As long as we're finding 30 or 45 or 60-degree angles, it's really not too bad. And quite possibly the easiest of them all. Let's go now to the fourth circuit on your page 1 of your notes.
What do we got? 90 degrees.
You're right. Very good. What was the last one? Well done, sir. Well done. So yes, what we're going to now go over is we're going to go over our quadrant angles. And as Max just identified, one of those quadrant angles is 90 degrees. What's another quadrant angle? 180. The other? 270. And then lastly, 360. Is it just 360?
And 0.
And 0. There you go. Good. Now, these quadrant angles have some coordinates that are a lot more friendly. Here it's 1, 0. Here it's 0, 1. Over here, -1, 0. And over here, 0, -1. Okay, I have given you your cosine and sine values of your quadrant angles. What's going to be your tangent value here for a 0 or 360? 0. Awesome. 0, because from here, from there to there, that's a horizontal line. That's a 0 slope. So our tangent value is 0. What about up here? Vertical line. What's your tangent value?
105.
Beautiful. 180 degrees, your tangent value is 0. 270 degrees, your tangent value is undefined. That takes care of page 1. Let's go over to page 2. I had a wonderful question earlier. And by the way, I've had this question every single class up to this point. And do we need to memorize all these numbers? Yeah, you do. Because odds are in your next test, you're going to see a blank page just like this. And it's going to give you this blank chart, this blank coordinate plane, and it's up to you to fill it in. Now, odds are, and I don't know this, but odds are this actually won't be graded. But if you don't know this, it's going to make filling in this stuff a lot more difficult. So what we're going to do now is we're going to come up with a little cheat sheet that's going to help us with solving the rest of these. Yes. Okay.
Can I have the formulas for?
Dang it. Yes. Okay. Give me 1 second.
I tried to do it without overfilling.
You know what? That's happening. Sorry.
It's okay.
Everything perfect and ready to go. All right, let's start filling this in. Sine of theta for a 30-degree angle, that is 1/2. Cosine of theta 30-degree angle, that is √3/2. And tangent of theta of a 30-degree angle is √3/3. This is all information you filled out in quadrant 1 for your 30-degree family circle. 45 degrees sine, √2/2 cosine, √2/2 with the tangency of 1. You've already filled all that stuff out for your second circle, 45-degree family. And then lastly, your 60 degrees. Sine of theta for a 60 degree is going to be √3/2. Cosine will be 1/2 with a tangent value of √3. And now this little coordinate plane here, we're going to use to help us with our signage. Now, coordinate 1, doesn't matter the family, 30-degree family, 45-degree family, 60-degree family. What do all the signs have in common for coordinate 1 functions? Are they all positive or negative? They're all positive. Good. So if you'll write this down, CAST, CAST. That's going to let you know which values are positive in their respective quadrant. So everything in quadrant 1, all of them are positive. Only sine is positive in quadrant 2. Only tangent is positive in quadrant 3. And only cosine is positive in quadrant 4. So now we can get to it. So if they wanted us to solve, what is sine of 45 degrees? This little think space here, if you want, you could plot. Okay, sine of 45 degrees. Well, a 45-degree terminal angle would be right about there. That's in quadrant 1, where all things are positive. Quadrant 1, where all things are positive. So if I need to know the sine value of a 45-degree angle, we're going to look at the 45-degree column. And we need the sine value in particular. Try to block all that out. Well, the sine value of a 45-degree angle is √2/2. So your answer is √2/2. Try cosine of 60 degrees if you haven't yet. you get 1/2? Yay. I'm gonna use a bigger piece of paper. Because here we're gonna have a little bit of a review. If we're about to do tangent of a negative 45-degree angle, starting from the positive x-axis, remember negative angles, we don't go counterclockwise. We have to go clockwise. So if I were to plot negative 45 degrees, it would be right about here. Meaning we are in quadrant 4, where the only thing positive in quadrant 4 is cosine. So now we can look at our 45-degree angles. We're looking for cosine, which would be here. And it's going to be positive. So your final answer will be √2/2.
It's tangent, right?
Oh, is it? I was looking at the wrong one. Tangent. Oh, you're right. It is tangent, not cosine. Thank you for pointing that out. All right. Well, the tangent value of 45 degrees is 1. And what's the only thing that's going to be positive in quadrant 4? Cosine. So what's my final answer? -1. There you go. Thank you so much for pointing that out. -1. Sine of 30 degrees, too easy. How about tangent of 225? Okay, 225-degree rotation from the positive x-axis. Going to be a little bit more than 180 degrees. Right about there. Okay, now I don't know if you're going to be able to see this, but on your day 1 notes, it gave you that little cheat sheet right there. This is how you can find your quadrant angles, or your reference angles, I'm sorry, based on which quadrant does it fall in. Well, this degree measurement here, 225 degrees, falls in quadrant 3. So if we take 225 degrees, subtract 180, it's going to tell us what our reference angle is. And 225 degrees minus 180 is 45 degrees. Therefore, we can use the 45-degree cheat sheet. Looking at the 45-degree column, what are we looking for this time? Tangent, tangent, okay. I want to write that down so I don't forget. Tangent. Well, the tangent value of a 45-degree reference angle is going to be 1. The only thing positive in quadrant 3 does happen to be tangent, so we're going to keep it +1. Yes, no, maybe so. What do we think? All right, turn over to the last page. You can cross out that bottom portion. I don't want to worry about that too much. Just because we have not gone over very many of these, I want to point something out to you real quickly. In order to find cosine of 90, tangent of 180, that's going to be that 4th circle of your notes. Those are all of your quadrant angles. So to find cosine of 90, here's 90 degrees. Our cosine value is 0. So you can just put 0. That's it. Tangent of 180 degrees, here's 180 degrees. Our tangent value is 0 once again. And so on and so on. Okay, here's what I want you to do. Fill in the rest. Start working on those. I will do them myself so that you can check to see if you're getting them right. I'm gonna keep going. If you are finished, you can go ahead and start on your Delta math assignment. Unit 3, day 2. Unit 3, day 2. If you need any help, please let me know.